Welcome to our journey into the science of perfectly tender chicken. Today, we'll explore how an incredible enzyme derived from papaya, known as papain, can transform ordinary chicken into a delicious, tender masterpiece.
Hello, we are from Group 7. We will present our project which is Papain as meat tenderized. Firstly, for enzyme mechanism, papain is a cysteine protease which catalyzes the hydrolytic cleavage of peptide bonds in meat proteins. Papain penetrates the chicken muscle tissue during the 30 minutes and 60 minutes of the enzymatic treatment to degrade myofibrillar protein like actin and myosin. This structural breakdown reduces the density and tension of the muscle fiber and increases the water-holding capacity of the tissue. Consequently, the meat becomes significantly tenderized and succulent texture, which is directly apparent in the final sensory score for juiciness and overall acceptability.
Moving on our methodology, our objective is to evaluate how papain treatment durations of 0, 30 and 60 minutes affect chicken meat tenderness. Our independent variable is the enzyme treatment time, the dependent variable is tenderness, and the concentration remains controlled across all groups. It shows in table 1, group T1 is for our control, T2 is treated for 30 minutes, and T3 for 60 minutes. To keep the taste consistent, all groups underwent a standardized 20-minute flavor marination of oyster sauce, soy sauce, and also black pepper. Looking at our 5-step procedure, we begin with sample preparation for uniformity, followed by papain marination for our specified times, and then flavor marination. After control cooking, we conducted sensory analysis using blind 3D coded samples to eliminate panelist bias. With this methodology established, let's dive into the results.
Next, I would like to present the sensory evaluation results of our papain-treated chicken samples. For this analysis, 3 samples were evaluated by panelists. Based on the results, the control sample consistently received the highest scores across all sensory attributes, including juiciness, appearance, texture, taste, and overall acceptability. The 30-minute papain treatment showed moderate sensory acceptance. The enzyme successfully tenderized the chicken while still maintaining an acceptable texture and eating quality. However, the 60 minutes papain treatment recorded the lowest scores for all sensory parameters. Panelists described the sample as overly soft and mushy, which negatively affected their eating experience. The ranking test further supported these findings. Sample 583 was ranked as the firmest sample, sample 716 as moderately tender, and sample 241 as the mushiest. This trend demonstrates that increasing papain treatment time progressively reduces meat firmness.
From our result, we can see that the longer the chicken is treated with papain enzyme, the softer the meat becomes. The control sample, sample 583, which was not treated with papain, has the highest firmness value of 3.895 kg. Consumers also prefer the sample the most because it has the best texture, taste, appearance, juiciness, and overall acceptability. For sample 716, which was treated with papain for 30 minutes, the firmness decreased to 2.710 kg. This means the enzyme successfully made the meat more tender, but the texture was still acceptable to consumers. However, when the treatment time was increased to 60 minutes in sample 241, the firmness dropped to only 1.553 kg. The meat became too soft and mushy. As a result, consumers gave it the lowest cost for texture and overall acceptability.
So I want to highlighting the industrial application of papain. So in the food industry, efficiency is everything, but not at the expense of quality. So from our research, that's confirmed that papain, a protease enzyme, acts as a natural catalyst for protein hydrolysis by breaking down to myofibrillar protein like actin and myosin. It transforms the meat structure at a molecule level. For industry, this translates into a major competitive advantage. We're talking about significantly reduced marination time, lower energy costs during thermal processing, and most importantly, consistent, high-quality texture and consumer demand. So it's a perfect example of how enzyme technology creates a more sustainability efficient and delicious food system.
As food technology advances, the role of enzymes like papain in cooking could be ever expanding. Imagine using these powerful tools to create textures and flavors that redefine our favorite dishes. In conclusion, papain isn't just an enzyme, it's a game changer for chicken preparation. With its remarkable ability to tenderize, it paves the way for future culinary innovation and enjoyment.